Okay. Hello everyone, my name is Deepak Akkil. I'm a doctoral student at University of Tampere in Finland. This is a work that I did during my summer internship at IBM Research Bangalore with my co-authors Prasenjit, who's also here, and Nitendra Rajput, who was then at IBM, now affiliated to InfoEdge India Limited, and Deepshika Salian, who was affiliated to Kids Preschool in Bangalore. Okay. There is an increasing use of technological devices by children between the age group of 4 to 6 years old for gaming, for entertainment, and also for learning purposes. Devices such as Apple iPads, Microsoft Surface tablets are being increasingly applied to early childhood pedagogical environments like preschools and kindergartens. Children become familiar using these devices at a very young age, providing scope for designing innovative and ubiquitous learning applications and experiences for them. Currently, touching the screen is the most common interaction technique in those mobile devices. It works better than an indirect interface like a mouse, for example, and it's much better than an interactive system is much better than simply viewing a video. But then there are also challenges with touch-based interaction for children. For example, children have very underdeveloped fine motor skills, which means that if there are complex actions required, it may be difficult for children. They are slower, they are more error-prone than adults, and they sometimes may not understand what needs to be done. For example, if there are complex gestures needed, it would need careful design of the stimuli to make children intuitively do this operation. And another important thing is that children get easily distracted from the learning activity. For example, a noise in the hallway or something colorful in somebody else's tablet screen, they would just get distracted, and sometimes these applications are unaware of these distractions and do not employ any means to get children's attention back. Depending on where the screen is placed, it may be difficult for children to interact with touch as well. Sometimes parents give children their mobile phones and tablets. Sometimes they prefer to place it on a table, for example, so that they don't fall and break. And that's also another consideration. Complementary input technologies like gaze tracking is soon expected to be available in mobile devices and tablet computers. There has been recent advancement in software and hardware technology that has made gaze tracking cheaper, accurate, and more ergonomic to use. And the technology is increasingly seen as a feasible input modality in mobile phones and tablet computers. The picture that you see are two commercial gaze tracking devices on the bottom, and on top it's an open source gaze tracking device that do not use any external hardware, simply using the forward-facing camera of a tablet. Gaze tracking for children. Gaze tracking has been done for children, for example, to diagnose psychiatric disorders at a very young age, for example, as an assistive technology for severely disabled users, and also to study development in development research, but not many studies have explored the use of gaze for interactional purposes for children between the age group of 4 to 6, and that's what we are trying to do. Gaze has very strong pedagogical value. It gives insight into a child's attention and interest as well, so that we could kind of integrate learning into their curious visual exploration. So there is a lot of potential for using gaze. Using gaze also means that the application is attention aware, so it knows when the child is distracted, and then it can also employ means to get the child's attention back when it's distracted. And also it could be used to augment and complement the current interaction methods that exist to provide a rich and embodied experience. Using gaze with children is also not without its set of challenges. For example, all gaze tracking devices need a calibration method, which normally works by showing predefined fixation points on screen where the user has to look at. Sometimes it can be challenging with kids to ask them to look at specific points. Children are restless, they move around a lot. That would mean that accuracy of tracking may not be that great sometimes. There are also differences in the fixation behavior of children. Children have smaller fixation duration than adults and less fixation stability than adults, which means that they cannot fixate at the same thing for longer duration as compared to adults. So maybe some long staring and gestural interaction with eyes may not be appropriate with children. So what we thought was, okay, well, how can we solve these problems, and how about we solve calibration with some kind of playful calibration procedure? And accuracy of tracking, if, for example, we can rely on interactions that do not need that high accuracy, maybe that's one way of dealing with it. And instead of using long staring, we could use gaze as an implicit way to understand the interest of the child and using that as in the interaction mechanics. And also employing a way to orient the child's attention back. So what we designed was something like this, a gaze-aware pedagogical agent. We call him Little Bear. It's an animated pedagogical agent that is designed to teach the names of some everyday fruits and vegetables, and it's also gaze-aware, so it knows where the child is looking at and responds both verbally and non-verbally based on the visual attention of the child. One of the learning benefit provided by a pedagogical agent is still debated in the child-computer interaction community, but a fairly well-established benefit of having a pedagogical agent is the motivational and engagement benefit that it provides. So taking all that into account, we designed this agent who speaks when the child interacts with it. The speech was powered by IBM Watson text-to-speech service. It also displays emotional responses in response to the gaze behavior of the child. We employed a calibration procedure. It was at the same time that Tobii IX provided a new update to their calibration, and we thought it suited perfectly for our need. The calibration process was such that it showed a circle on screen, and then when the child looked at it, the circle would burst, which had this playful element which we thought was well suited for kids. And also for our UI was segregated into smaller regions of interest, and they were fairly large, so that if the accuracy wasn't that high, it would still be possible to interact with it. We used rather short dwell time, so if the child looked at an area for 500 milliseconds, it was activated. That would mean that the agent would speak an interesting detail about the fruit, and during that period, the application was not responsive to gaze. So during that period, it doesn't matter where the child looks at, but then soon after the speech was over, and the agent talked about the next fruit that the child looked at. The short dwell time of 500 milliseconds was also considering some of the previous research in this area, which says that the median fixation duration of children viewing pictures is about 280 milliseconds. So we thought 500 milliseconds was a safe number to go with. Okay, we'll see a quick video of the work. Hopefully the audio works as well. No, it doesn't. Let's see. Okay, I'll start from the beginning. I'll try one more time.
Hello, I am your little bear. Can we be friends?
So the green dot is the gaze point of the user here.
I will tell you a little secret. I have eyes, and I can see where you are looking.
When the user gets distracted and looks away from the screen,
Oops, I become sad when you do not look at me. Oops, I become sad when you do not look at me.
and the little bear becomes happy when the user attends to the screen. Developed an application for early learners with the little bear as a central character. The application was designed to teach the names of some everyday fruits and vegetables.
Hello, now we are in the garden. There are so many interesting things in here. Let's walk through the garden and see what we find. Wow, we have found some new items. Do you know what these are?
The application could be interacted using gaze.
This fruit is apple. Have you heard? An apple a day keeps the doctor away. You are looking at raspberry. The name of this fruit is ugly fruit.
And we compared this against the baseline touch-based interaction.
That is jackfruit.
Okay, so we did a comparative study comparing this gaze-aware character with a conventional baseline character, which doesn't exhibit any emotion and which could be interacted using touch. Okay, now it doesn't go any further. Okay, we had 12 participants, 5 male and 7 female participants, all 5 years old. We made 2 lists of 20 fruits each, and both the lists were of comparable complexity, and we had 5 different phases where the interaction took place. At all phases, 4 fruits appeared. The children were free to look at them, interact with it as long as they wanted, and then they would press a button and then it would go to a new location, new fruits would appear, and so on. We used 4 independent variables to do our analysis. One was the duration of time that the children interacted with it. It was completely in their control how long they would interact. So we thought that would be a good measure of engagement of the application. The number of fruit that they activated, which would mean that they did not just interact with the agent or play with them, they also involved in the learning activity. After the test, we did a short test about the short-term retention. So we asked 10 questions about, okay, we showed them pictures and asked them which fruit is this, and in fact the other way around. So we showed them pictures and asked them, show me banana, for example, and they had to touch the picture of banana to answer it correctly. We also used a 5-point smiley meter based questionnaire. I will not go too much into that. Okay, so overall, children interacted much longer with the gaze-aware application. Per phase, about 110 seconds compared to a baseline of 50 seconds per phase. And also they activated much more fruits than using a baseline condition, where they activated each fruit only once or roughly slightly more. And in the gaze condition, they looked at each fruit for 2.5 on an average. And they did also slightly better with the short-term retention in the little bear condition compared to a baseline condition. There was, however, no difference in the smiley meter based questionnaire. Okay, so what does this say? It shows the feasibility and value of gaze-based interaction for children. Calibration was not a big issue. Accuracy of tracking was not a big issue for the interaction that we chose. Children could associate the fruit that they looked at and the verbal utterances of the character. Here the purpose is not to show that gaze could replace touch, for example, but there is a novel possibility of interaction with this modality, which could be complementary to the existing techniques. So what we were also surprised by the short-term retention. So what would result in such a thing was, maybe one thing we speculate is that children did engage much longer with the gaze-aware application, in fact twice as much. Maybe that meant that they also learned slightly better with the gaze-aware application. And also there has been previous research with adult users which seems to suggest that when there is a character which employs mechanisms to reorient the attention of the user focuses more on the learning activity, and it has and also has even provides deeper gains at a deeper level of comprehension of the task itself. Okay. We also had some other interesting observation. We thought using agent's emotion to regain the child visual attention was a useful technique. It helped like in 2 ways. One, when the child was distracted, it could help reorient the attention, and when, for example, the tracking did not work properly, when the child moved around a lot, that was also a cue that the child had to reposition themselves. It also required moderator intervention in the early phases, so that the moderator had to say, okay, you have to go a little bit closer, because their first instinct when the tracker did not work properly was to go really close and say that, why can't he still see me? I'm right here. My bear has bad eyes, and so on. Also, all participants reported that in the gaze, they did not want to make the character sad. There was also very interesting in the sense that there was a situation where there were multiple onlookers looking at the interaction, and they were talking to each other. The child wanted them to leave the room because they were interrupting, distracting the child, which in turn was making the character sad. Okay, I'll skip some other results and go to the limitations. The presence of a moderator was probably a limitation in our study. We should at some point look at teachers doing the studies themselves, because the moderator was external and children were not familiar. Small sample size, definitely. Positioning of the device was probably a key influence on our result as well, because the child had to lean and touch it. They were allowed to move forward and touch as they felt, but then probably that might have also influenced our result. The other option was that we could have given the tablet to the child, but then that could have also added a confound variable in our evaluation. This was a short-term evaluation. It altogether took 1 hour. There is probably a novelty effect as well. Would there be motivation to make the character keep happy in, for example, 2 months, 1 year down the line? We don't know yet. And I'll stop by saying that there's a demo available if you want to try it in the ground floor. Thank you so much, and I'll take questions if you have any.
Hello, hi, I'm Ambika. There's a wearable Tobii glass that is available in market. So you showed us iTribe and IX.
Yes.
Apart from that, there are other wearable devices that you could have used for like the fixation and all those things.
Yeah, well, of course, there are wearable eye trackers available as well, but then that's not something we wanted to go. We wanted a remote solution where the child did not have to wear something on their body.
Hi, thanks for the presentation. It was wonderful. I just have a question regarding the voice that you have used in the agent. What design choices did you make to choose that one?
We did want the voice to kind of fit to the character, so a little bit cartoony, and then we also controlled for the pace so that it wasn't too fast or it wasn't too slow either. We also controlled for the pauses at the right place so that it was easy to understand for the kid, and also the language was, we tried to keep it as simple as possible.
Thank you.
Hi, Janet Weston. First of all, thank you for a very interesting presentation. You said that the children took longer to interact with the eye gaze condition rather than the touch condition. But doesn't it just physically take longer to recognize a gaze than it does to do a touch?
What do you mean? Does it?
Well, you say they interacted longer. Is that not just a natural consequence that eye gaze typically has a timing factor? That you in terms of focusing a fixation point, you can set a time limit. And typically touch is much faster than those time limits.
Okay, yeah. Well, if that was the case, it would have also showed in the number of activations per fruit, for example. That should have been still comparable in that case.
Hello, sir. So the idea deals, like, this seems to be very exploratory stuff. But I had a concern about we always trying to let the child gaze on the screen, and I hope this doesn't, on a long-term basis, this doesn't lead to any psychological disorder in terms of attention deficit disorder. Because every time the child kind of moves his head away, the bear always kind of tries to get back his attention. In the long term, it should not, I had a concern, it should not kind of create some neural networks that might always help the child to get attention from someone, like while he's teaching. How do you kind of tackle those situations?
I have the same concern in general use of technology, but then that's something we should use in an appropriate way, so that maybe too much is too bad and too little is not good either. So we should probably strike the right balance here.
Okay, look, another question, but this relates to the attention deficit. I have a little grandson of 9 with attention deficit, and he's been on a Concerta on a trial basis. And he says that when he's on Concerta, he doesn't hear the noise around him, and it enables him to focus on the teacher. So I think rather than accentuating or aggravating attention deficit, eye gaze could actually improve it.
I agree.
One last question. So gaze as by the way, Jonathan. So using gaze as a way to improve or talk about novelty as touch. Could there be a way by which your gaze can collaborate so that when a lot of children, say one or two children together look at, say, an interactive media, how would that respond? Because your entire sample size was only a one-on-one collaboration. But generally, when you have a lot of kids, or maybe even 1+2, the entire effect of what you're talking about would be very, very drastic. So if you are planning to explore this with more than one kid while looking at it, what could be your initial steps that you would take to use gaze?
That's one thing we also discuss extensively in the paper. It's right now as it is, it's not very conducive to collaborative learning for two reasons. One is that currently gaze tracking technology itself doesn't support more than one user, and also the fact that when there are multiple users, they would look around to the other user, for example, and then the bear would become sad and so on. We haven't really thought about going how we would be going in that direction, but definitely that will be something we'll look at in the future.
So you're primarily using gaze as a method of taking a longer time to select, right? So do you see this more as, do you see this as a standalone, or is it always meant to be a complementary with touch? Because I didn't see the selection exactly happening.
That's also a very good question and something we discuss extensively in the paper. That's also something we tried in one of our following user study, where we tried to combine gaze with touch, but then we ran into serious problems with kids because one is that they have small hands and eye trackers have an optimal working distance of 30 to 40 centimeters. So they would really go close to touch, which means the tracker doesn't work as well as it should ideally work. And also when they want to touch, they would place the device very differently, for example, on the ground and so on, and the tracker doesn't see the eye. So there are technological improvements required to go in that direction, yes. All right, thank you so much.